Morning, everyone. Ms. Hall here with lesson 24. Today we are going to be working on solving word problems using fraction and decimal multiplication. So you're going to need your problem set for lesson 24. You'll notice that all of the problems are word problems. We are not going to go through all of them. We're going to go through numbers 1, 3, and 5. Okay, so I'm going to start with problem 1. So remember, we want to read the problem 3 times. So go ahead and preview that problem on your own. So it says a vial contains 20 milliliters of medicine. If each dose is 1/8 of the vial, how many milliliters is each dose? Express your answer as a decimal. Okay, so a vial contains 20 milliliters of medicine. So a vial of medicine, think of it like a pill bottle kind of thing. So if there's 20 milliliters in there, okay, so a vial contains 20 milliliters of medicine. If each dose, so that's how much you would take, is 1/8 of the vial, how many milliliters is each dose? So I'm going to start with a visual. This is going to represent my vial, and the whole thing I know has 20 milliliters of medicine. I also know that the vial is split up into eighths. So if I need 8 parts, I'll draw 7 lines. So 1, 3, 4, 5, 6, 7. So go ahead and draw your visual. And I am looking for 1 part because I want to know what each dose is worth, how many milliliters. So right now, I know that I have 8 units, and that whole thing is 20 milliliters. What I'm looking for is just 1 unit. That's what I'm trying to figure out. So if I have 20 milliliters and it's split into 8 parts, I'm trying to find 1/8 of the 20 milliliters. We know that if we're finding a fraction of something, that we have to multiply. So I'm going to do 1/8 times 20 milliliters. So to multiply that, I would do 1 times 20 over 8. Okay. And that would be 20 over 8. But we don't want to express our number of milliliters as a fraction. We have to express it as a decimal. So how could I turn that into a decimal? First of all, I notice that it's a mixed number. So what I want to do is find out how many wholes are in there, because the top number is bigger than the denominator. So I'm going to think, how many times does 8 go into 20? So you might want to look at a multiplication chart if that helps you. I am thinking of my 8's facts, and I know that 8 times 2 is 16. And that would leave 4 left over. So I'm going to have 2 wholes in here. So 8 times 2 is 16. That leaves 4 left. So 4/8. Okay. Now I'm still not ready to make this into a decimal yet, because I'm not sure if with an 8 in the denominator, that doesn't easily convert to a decimal. So I see that I can reduce this. Both of them can be divided by 4. So if I have 2 wholes still, 4 divided by 4 is 1. 8 divided by 4 is 2. So I have 2 and 1/2. I'm almost done, but I have to get to a decimal. So you might be thinking, well, I know what 1/2 is as a decimal. But if you don't, we can think back to a few lessons ago when we were trying to get the denominator to end up as a 10, 100, or 1,000. So I know that I can multiply this 2 by 5, and I would get a 10 in the denominator. So if I multiply by 5 on the top and the bottom, I still have 2 wholes, and now I have 5 on the top and 10 on the bottom. So now that I have tenths, I can look right here at my place value chart, and I see that tenths are 1 digit after the decimal. So I'm going to keep the 2 as the whole number in front of the decimal. And then 5 tenths, the 5 goes in the tenths place. So we have 2 and 5 tenths milliliters. So each dose is 2 and 5 tenths milliliters. Okay. And then, of course, we would write an answer statement. So each dose is 2 and 5 tenths milliliters. Okay, good job. I'm seeing people saying easy. That's awesome. All right. The next problem we'll do is problem 3. So start looking at problem 3. Read that one to yourself while I get ready. All right. So Andres completed a 5-kilometer race in 13 and 5/10 minutes. His sister's time was 1 1/2 times longer than his time. How long in minutes did it take his sister to run the race? Okay, so there's a lot of numbers in there. Let's see what it's really important. So Andres completed a 5-kilometer race in 13 and 5/10 minutes. Well, I know that the question is about how long it took, not how long the race is. So this 5 kilometers thing doesn't really matter. It could have been a 2-mile race. It doesn't matter. We're talking about the length of time it took. So Andres completed a race in 13 and 5/10 minutes. His sister's time was 1 1/2 times longer than his time. How long in minutes did it take his sister to run the race? So let's do a visual. I see some people are commenting with kilometers, but we're not doing the distance. We're doing the minutes it took. So what do we know? We know that he ran the race in 13.5 minutes. 13 and 5/10 minutes. Now his sister, it took her 1 1/2 times as long. So the 1 is the same amount. Okay. She spent 13 and 5/10 minutes, but then she also spent another half of that time. So how will I figure out this part of her time? I have to take what I know, the 13 and 5/10, and I'm going to find a half of that. So if I'm finding a half of something, what operation is that? We did this on the last one. Right. We're going to multiply. So 13 and 5/10 times 1/2. That looks really strange because I have a decimal here and then I have a fraction over here. And we want to use the same format. So I'm either going to change this to a fraction or I'm going to change this to a decimal. You can do it however you want. I am going to change 1/2 into a decimal because that's one that's in my head. I know that 1/2 is equal to 0.5, 5/10. So I'm going to rewrite that as a decimal multiplication expression. Okay. Now I have to set up my standard algorithm. So when I'm multiplying with decimals, remember we pull the decimals right out. I took out that decimal and just wrote 135, but it's not 135. It's 135. This only goes to the tenths place, so it's 135 tenths. And then I'm going to multiply by 5 tenths. I don't need the 0 in the front. I'm just going to use the 5. Now I'm ready to multiply. 5 times 5, I get 25. 5 times 3, 15, plus 2, 17. 5 times 1 is 5, plus 1 is 6. Okay, so I got 675. But I can't forget about the units. These were both tenths. So if I did 10 times 10, I would have hundredths. So my new unit here for my answer is hundredths. So I have 675 hundredths. I have to think about what does hundredths look like. So if I look at my place value chart, I see that hundredths are 2 places after the decimal. So I am going to rewrite the number, and I'm going to place my decimal point so that I have 2 digits after the decimal. So if I put it here, that would not work because I'd only have tenths. If I put it here, now I have tenths and hundredths. So I'm not done yet because that is only this half of the 1.5 times that she took longer than her brother. So I'm going to put this in here. I now know that portion was 6 75 hundredths of a minute. I have to find how long it took her to run the race. So I want to total up both portions of her time. So I'm going to add now 13 and 5 tenths. And when I add with decimals, I want to line up my place values. So that basically just means I'm going to line up where the decimal is. So make sure that your decimal points are lined up. And I don't like this empty space here, so I can add a 0. And then we're ready to add. So 0 plus 5 is 5. 5 plus 7 is 12. Decimal there. 3 and 1 is 4, plus 6 is 10. 1 and 1 is 2. So it took his sister 20 and 25 hundredths minutes to run the race. So we would do our answer statement. His sister ran the race in 25 hundredths minutes. Don't forget that answer statement with your unit on there. Okay. All right, the next one we're going to do is number 5. So when you're ready, turn to number 5. If you're having trouble with this one, you can go back and rewatch it. You can rewind and back it up. Pause the video after each step so you can slow down and do it with me. Okay, so get ready to read number 5 to yourself while I get ready. Okay, here we go. There are 3/4 as many boys as girls in a class of 5th graders. If there are 35 students in the class, how many are girls? Okay, so this one is a challenge because we kind of have to work backwards. We know the total amount, and we know that there are 3/4 as many boys as girls, but we don't know how many girls there are. So, how can we find a fraction of something when we don't know how many there are? Let me show you what we're going to do. We're going to represent the boys and the girls with tape diagrams. Okay, so I'm going to represent girls first. And we're talking about fourths. So I'm going to split this into fourths. The boys only have 3/4 as many. So I'm not going to make this tape diagram as long. I'm only going to draw it as long as 3 of those parts. So we don't know how many girls there are yet, but we know that to find the number of boys and girls, we have to find 3/4 of the 4/4. What else do we know? We know that the total is 35 kids. Okay, so what do I know? I know that I have 4, 5, 6. I have 7 units that all equal the 35 kids. To be able to figure out how many girls and how many boys, we need to know what is one box worth. Okay, so we're going to find 1 unit. This probably reminds me of number 1 because we know a total and we have to figure out what 1 unit is for. So how will I find what 1 unit is? Well, I know the total and I know that there are 7. So if we take 35 and divide it by 7, we get 5. So each one of these units is 5. So I can fill that in. So what I did was 35 divided by 7 equals 5. The 7 was because I have 7 units in all. So let's revisit the question. If there are 35 students in the class, how many are girls? So let's look back at the girls diagram here. I have 4 units and each one is worth 5. So if 1 unit equals 5, then the 4 units I have equal, well, let's figure it out. 5 times 4 equals 20. Okay. So to answer my question, there are 20 girls in 5th grade. Okay. So remember that today you have to do a lot of reading the problems and rereading the problems. Your visuals are going to help. You will be using decimals and fractions. And if you're doing a problem where it gives you a fraction and a decimal, you have to put them in the same format. Okay, either work with all fractions or all decimals. It's your choice. Okay, so great job. I love the responses I'm seeing on comments right now. You guys are going to go ahead and do the exit ticket and put your responses online, and we'll send you some feedback. And have a great day.